Section 6 of Chapter 2 is the last section. We're almost done. Solving linear inequalities. So we know that inequalities are just like equations except they're not equal. So we're going to use less than, greater than, less than or equal to, or greater than or equal to. So it's just like an equation except that it's not equal. All right. And the fact that they're linear, remember, linear equations and linear inequalities, the same thing that makes one linear makes the other linear. All the variables have exponent of 1. So if you have any squared terms or any cubed terms or to the fourth or to the fifth power, if there's any power on those variables, it's not linear, and that's not what we're talking about. All right, so solving linear equalities, when you get the solution, you need to be able to show it. I've got a few different ways that you can show show your answer to a linear inequality. So in this case, we have x is less than or equal to -6. The first type of solution set is called the set builder notation, and it looks like this. It's going to be x such that x is less than or equal to -6. And then you're going to put those in brackets, which indicates the set. All right, the set of x such that x is less than or equal to -6. All right, so that's set builder notation. Interval notation is going to be, you're going to have it in just in the two ends. So the interval notation shows, well, what are the ends? Which way is my solution going? So in this case, the x is going to be less than or equal to -6. So -6 is the right-hand end, and the left-hand end goes on and on and on forever. So we're going to have the left-hand end be -infinity. All right? And then we're going to show if it's just less than or equal, or if it's less than or greater than, we're going to use just parentheses. If it's less than or equal to, we're going to use brackets like this. All right, so if it's got an equal to, it's the square brackets. If it's just less than or equal, or less than or greater than, then it's just the rounded parentheses. All right, so then your graph is going to use this same type of notation. So we have -6 as our endpoint, and it's a hard endpoint. It means it's included, so it's going to have the bracket, and it's everything less than -6. So you're going to shade what's less. All right. Now that I've shown all of this to you, I'm going to make it worth your while that you watch this video. In your book, it's going to ask for all three of these. I don't necessarily care that you write this notation. I want you to recognize it. If you are in a college class and that's the way the teacher wants it shown, I want you to recognize, so I wanted to show it to you. I want you to use this interval notation, and I do want you to graph it. So in all of those problems that say show them all three ways, you don't have to do the set builder notation. All right? Okay, moving on. So let's use that interval notation to show a compound inequality. So this says 1 is less than x is less than 6. So we've got 1 and 6 are our endpoints, and x is going to be in between there. So 1 and 6 are our endpoints, and because they're not equal to, I'm going to have parentheses. So that is my interval notation for the answer to 1 is less than x is less than 6. That's the set. So when you're graphing it, you're going to graph the two endpoints, 1 and 6, and you're going to put the parentheses to show the soft endpoints and graph what's in between. All right? Let's do another one. -5 is less than or equal to x is less than 1. Shut it off and try to do it yourself, or try to beat me. All right? I want to see if you can do it. Here we go. -5 and 1 are your endpoints. -5 and 1. -5 has an equal to, so it has a hard endpoint, and less than here has a soft endpoint. So when you graph, it's going to look exactly like that. -5 and 1 are your endpoints. -5 is equal to, 1 is not equal to. There you go, graph them. All right, so now you know how to show your solution. Now let's solve a few. So we want to solve x plus 2 is less than or equal to negative 3. You're going to solve these exactly the same way that you solved equations, except keep that sign, don't lose it. All right, so in this case, we added something to x, so we're just going to subtract the same thing. So subtract 2 just like you would with an equation. So now x is what's left on this side. X is less than or equal to negative 3 and a negative 2 is negative 5. There's the solution. All right, 3x is greater than negative 7. Same thing here. This time they multiplied, so you're going to divide to undo it. So divide by 3 on both sides. So x is greater than, and it doesn't have an equal, so your answer doesn't have an equal. And this won't divide, so you can just leave it negative 7/3, and you're done. All right, let's do one more similar to that, because there's a big star. I want you to put a big old star in your notes, and I want you to notate if you divide by a negative, change the direction of the sign. Okay, have this somewhere in your notes so that you remember it, okay, with a big star, big something. All right, so we've got negative 8 times x is less than or equal to 24. So x was multiplied by a negative 8, so I'm going to have to divide by a negative 8, which is fine. I can do that on both sides. But when I do that, don't forget. So now I divided by negative 8, so x is not less than or anymore. It's greater than or equal to negative 3. Okay? So if you divide by a negative, not if there's a negative over here, but if you divide by the negative, you're going to switch the sides. All right? Okay, let's do one more of this kind. I want to give you a little bit more complex. Let's solve another one. Where's my example here? Here's the problem. Oh man, I got it. All right, lid here. All right, 7x plus 9 is greater than 4x minus 6. All right, and all of those I didn't give you the interval notation on it, did I? All right, we'll do it on this one. Here we go. So the same type of thing, exactly the way you would solve this if it was an equation. You've got x's on both sides of the inequality. You got to get them together. So let's subtract the 4x from both sides. So now 3x plus 9 is greater than a negative 6. So now let's subtract the 9. 3x is greater than 9, 10, 15, negative 15. Divide by 3. And this is what I was talking about. We're dividing by a positive. Even though there's a negative over here, we're dividing by a positive, so the sign stays the same. So x is greater than negative 5. So our set notation is, let's see, so if it's greater than 5, everything greater than 5, or negative 5, so negative 5 is this end, and everything greater than that is infinity. It's going to go on and on and on and on to the right. All right? So negative 5 to infinity is x is greater than negative 5. All right, oh, and you can graph it by putting negative 5, everything to this side, and it's a soft. All right, here we go. I have two more things. The next thing is this. You can solve this type of problem even if it's written out. So on page 150, you will find a little chart of the of terms that you can use for greater than or less than. A lot of them are really simple. It just says is greater than or is less than. The two that I want you to notate, make sure you put stars or X's or something by in your notes or something, because the ones that trick me anyway is at least and at most. So when you're reading through a word problem and you're having to use an inequality, if you want something to be at least something, it sounds like less than because it's saying least, but if it's at least, that means it's got to be bigger than that because this is the very smallest it could be. So at least means greater than, and at most means less than. Okay, so put those somewhere so that you remember. At least means it's got to be bigger than that. This is the very smallest it can be. At most means it's got to be At most means it's got to be smaller than this. This is the very most. This is the top end, okay? So those two, make sure you notate and look at page 150 for more of those. All right. So what we're going to have is you're going to need to translate words into numbers, which you've done before with the equations. Let's do it with inequalities now. 3/4 of a number is at least 18. Translate that into an inequality and solve it. So 3/4 of means times 3/4 of a number, so just call it n or x or z or whatever you want to call it. 3/4 of a number is at least, so this is where our greater than comes in, is at least 18. And if it's at least, then that means it can be 18, right? So is greater than or equal to 18. So now to solve this, we simply divide by what they multiplied by. And remember, if you divide by a fraction, you just flip it and multiply. Because if you flip this and say 4/3, zip, zip, now all of a sudden we just have n left. We did that on this side, so we multiply by 4/3 on this side. And 18, remember, is 3 times 6. So our 3's can cancel. And 6 times 4 is 24. So n is greater than or equal to 24. All right? Next. Oh, what am I thinking? I always forget to do the set notation. Don't forget that. Okay, so now we have to show, well, what is this? If n is greater than 24, that means 24 is this end point, and it's a hard end point, and it's going to go on and on and on and on to infinity. So there's your set notation. All right? You knew I wouldn't let you get away without doing a word problem, so here we go. Danny is planning an enclosed garden area. Cost restricts him to 240 feet of fencing. He wants the garden to span the 80 feet of his lot. What is the maximum length that he can possibly have? So what we've got to do is we've got to figure out what the perimeter is going to be, right? Because we're talking about a fence. So here's our garden. And he wants the garden to span the 80 feet. And this is our x. We want to know how long can we make this? I guess I drew it the wrong way. What's the maximum length it can be? So the perimeter, remember, is the perimeter of something is 2 times the length plus 2 times the width equals perimeter. And so what we want to do is we want to do 2 times the length plus 2 times our 80. And we want the perimeter has to be 240 is the biggest it can be. All right? So if 240 is the very biggest, then that means this has to be less than 240, right? If we multiply all of this together and add it together, this answer has to be less than or equal to 240. All right? So now we multiply it out. 2L plus 160, 18 or 16, yes, is less than 240. Now we just solve it. Subtract 160. 80, 8, 9, 11, 12, yep. So 2 times the length equals 80. Equals is less than or equal to, don't lose that. Divide by 2. So the length is going to be less than or equal to 40 feet. Don't forget to label those word problems. A lot of you are missing little points just because you don't label them. If you've got a word problem, your answer must have some sort of label. Okay? So your length is going to be less than or equal to 40. 40 is the biggest it can be. So the max length, what is the maximum length? The maximum length is 40 feet. There you go. Solving linear inequalities. I'll see you soon.